January 16th, 1943, 06:42 a.m. Bethlehem Fairfield Shipyard, Baltimore, Maryland. The cold comes first. It creeps up from the concrete, through the soles of your boots, into your legs, until your knees ache before the day is even started. A gray winter dawn hangs over the yard, the sky low and heavy, pressing down on the rows of unfinished hulls like a lid that won't quite close. Somewhere down the line, steel rings. Not a hammer strike, not the hiss of a torch. A sharp, hollow crack, the sound of something failing. Men freeze. For half a second, nobody moves. Then someone swears. Another man drops his gloves and jogs toward the noise, breath puffing white in the air. A foreman's voice cuts through the din, tight and angry, ordering everyone to stand clear. On slipway number 3, a Liberty ship hull, 300 feet of welded steel, barely weeks old, has split along a seam near the deck edge. The crack isn't dramatic. It doesn't explode or tear open in a shower of sparks. It just opens, quietly, like a zipper pulled too fast. You can almost feel the dread settle in, because this isn't the first time. Frank O'Connor arrives seconds later. He doesn't run. He never does. He walks fast, shoulders hunched inside a heavy coat, stained with oil and soot, eyes already scanning the hull before anyone finishes explaining. He's a civilian, a dock worker, a foreman with no engineering degree, no officer's bars, no authority beyond the men who trust him. And he has seen this crack before. Up close, it's worse. The steel plate has fractured cleanly along a weld line, the metal crystalline at the edges, like broken glass. O'Connor reaches out without thinking, fingers brushing the seam, feeling the cold bite through his glove. "Same place," he mutters. A Navy inspector stands nearby, clipboard tucked under his arm, jaw clenched. He doesn't write anything yet. He already knows what this means. Another ship delayed, another hull flagged, another investigation. Behind them, the yard keeps moving. Torches flare, cranes groan. Welders keep laying beads along seams, sparks raining down like metallic snow. There is no pause button on this place. Not anymore. Across the Atlantic, men are freezing in convoy lanes. Ammunition is being rationed. Food is being stretched thin. Every Liberty ship matters, not as an idea, not as a symbol, but as tonnage, as fuel, as time. And this one might never sail. O'Connor straightens and looks down the line of hulls stretching into the fog. He counts them without realizing it. He always does. 47 ships in various stages of completion, each one welded faster than the last, each one built by men and women who a year ago had never touched a torch. That's the miracle everyone talks about. What no one wants to talk about are the cracks. The inspectors say it's the steel, brittle in the cold, rolled too fast, wartime shortcuts. Metallurgists argue over grain structure and impurities, their reports thick with equations and uncertainty. O'Connor listens to all of it. And then he watches the welders work. He watches how seams are laid in long, continuous runs, chasing speed targets posted on chalkboards at the end of every shift. He watches heat bloom and fade across the plates, stresses building invisibly, locked into the hull like coiled wire. He watches ships come apart, not at sea, but right here, under American flags and motivational posters promising victory through output. One Liberty ship had broken clean in half at the pier in Portland, Oregon. Another fractured during sea trials. Men whispered about it in the yard, voices low, like talking about a disease you might catch. They weren't supposed to fail like this. They were supposed to be simple, ugly, strong. "Frank," one of the welders says quietly, nodding toward the crack. "They're going to shut this one down." O'Connor exhales slowly. He knows. He also knows something else. The official fixes aren't working. The Navy has already ordered changes, thicker steel in some areas, reinforcement straps in others. Production slows. then speeds back up, then slows again. Every adjustment comes with paperwork, approval chains, signatures from men who don't stand in the cold at 6 in the morning. Meanwhile, the cracks keep coming. O'Connor walks the length of the hull, boots echoing dully on steel. He stops where 3 major weld seams intersect: longitudinal, transverse, vertical. A perfect storm of stress. He crouches, ignoring the ache in his knees, and stares. You can almost see the ship as it will be at sea, waves lifting her bow, cold Atlantic water slamming against the plates, steel expanding and contracting with every mile. Something about the way these seams are laid bothers him. Not the quality. The welds are clean, strong. The order. They always weld the long seams first, then the cross seams, then the verticals, always in the same sequence. It's efficient, repeatable, easy to train, and it locks stress into the hull like a trap. O'Connor straightens again, heart beating faster now, not from the cold, from the idea. He's thought about this before, late at night, staring at the ceiling while his hands still smell faintly of burned flux. He's mentioned it once or twice casually to other foremen. They'd shrugged. That's engineering's problem. Engineering, however, hasn't fixed it. A supervisor approaches, face set in that familiar mask of controlled frustration. "Frank, Navy wants a full report, same as last time. We'll brace it, cut out the bad section, re-weld." O'Connor nods. Yeah, but his eyes are still on the seam. He knows what he's not supposed to do. He's not supposed to change procedures without authorization, not in wartime, not with inspectors watching, not when the entire Allied supply chain rides on standardized processes. But he also knows something else. If these ships keep cracking, none of it matters. That night, after the shift ends and the yard lights cast long shadows across the hulls, O'Connor stays behind. He walks the slips one last time, listening to the cooling steel tick softly as it contracts in the cold. He stops beside another hull, nearly complete, welds still fresh. Tomorrow, they'll start on the final seam. O'Connor rests a gloved hand against the steel and makes a decision no one has asked him to make. Not yet.
The rule was simple. Weld fast, weld straight, weld the same way every time. In the chaos of wartime shipbuilding, consistency was survival. Thousands of new workers flooded into yards like Bethlehem Fairfield, farmhands, seamstresses, mechanics, teachers, people who had never stood inside a steel hull before. The only way to turn them into shipbuilders in weeks instead of years was repetition. Procedures were written, simplified, drilled until muscle memory took over. Long seams first, then cross seams, then verticals, always in that order. Frank O'Connor knew the rule as well as anyone. He had helped teach it. He had enforced it. He had defended it when inspectors questioned productivity numbers. And now, standing alone beside the half-finished hull in the cold, he couldn't stop thinking about what the rule was doing to the steel. You could almost feel it if you imagine it long enough. The heat from a weld racing ahead of the torch, metal expanding under intense temperature, then cooling and shrinking again. Each pass locks stress into the plate, invisible but real. When you weld the longest seams first, that stress has nowhere to go. Every shorter seam added afterward tightens the knot. O'Connor had learned this the hard way years earlier, repairing cracked barges on the Ohio River in winter. Different scale, same steel, same physics. Back then, he'd learned to break up heat, to move around, to let metal breathe. But Liberty ships weren't barges. They were bigger, thinner, built faster than anything had ever been built before. And they were failing in ways no one expected. The next morning, O'Connor brings the idea up again, carefully, during a break. The welders sit on overturned crates, steaming coffee cups in gloved hands. Someone is laughing about something unrelated, the sound sharp against the grinding background noise. "What if," O'Connor says casually, "we didn't chase the long seams straight through?" A few heads turn. "Meaning?" one man asks. "Meaning we stagger it, jump around, let the heat settle before we lock it all in." Does a pause. "That's not how it's done," another welder says. Not hostile, just factual. "I know, but that's how cracks happen." The men glance at each other. They've seen the cracks too. Everyone has. But changing process feels dangerous in its own way. Mistakes get ships delayed. Delays get people noticed. Not in a good way. "Engineering never sign off on that," someone mutters. O'Connor nods. They don't have to. The words hung there longer than he intended. That afternoon, a Navy metallurgist arrives to inspect Slipway 3. He lectures about brittle fracture, about temperature gradients, about material properties. He gestures with his clipboard, explaining why reinforcing straps might be added near deck edges. O'Connor listens respectfully. Then he asks a question. What if the problem isn't the steel, but when we're telling it to move? The metallurgist blinks. "Excuse me?" "The order we weld it in," O'Connor continues. "We heat one path end to end, then lock it in place before anything else moves. That stress has nowhere to go." The metallurgist frowns. "Procedures were designed for speed and uniformity." "I know, but speed's not helping if the ship breaks." The inspector writes something down. Or maybe he doesn't. It's hard to tell. Nothing changes. By week's end, another Liberty ship is flagged. Hairline crack near the deck. Same region, same pattern, same story. O'Connor feels the pressure building, not from supervisors, but from time. Convoys are being delayed. Losses are mounting. German U-boats don't care how fast the ship was built if it doesn't survive its first winter crossing. One night, as snow flurries swirl between the hulls, O'Connor makes his decision. He won't change everything, just one thing, on one ship, quietly. The next morning, he pulls aside a small welding crew assigned to a new hull section, men he trusts, men who've worked with him long enough to read his face. "We're gonna try something different," he tells them, "just on this one." "What kind of different?" one asks. O'Connor points to the chalk marks outlining the scene plan. "We don't run it straight through," he says. "We skip, we stagger, we come back later." "That's not the book," someone says. "I know, but I'm watching this one, myself." The crew hesitates. Then one man shrugs. "Hell, it's steel. It won't tell on us." They begin. The torch flares, sparks shower the deck, but instead of chasing the seam end to end, they stop, move, let the heat bleed off, come back from a different angle. The rhythm feels wrong at first, like writing with your offhand. O'Connor watches closely. He feels like he's standing on a fault line, waiting to see which way the ground will break. Inspectors pass by without noticing. Supervisors check production boards and move on. No alarms, no whistles. By the end of the shift, the seams look normal. Better than normal. That night, O'Connor walks the hull again, hand resting against the steel as it cools. The ticking sound is different, slower, less sharp. You can almost feel the stress easing, redistributing, settling instead of snapping. It's not proof, not yet. The real test will come later, when the ship is finished, launched and exposed to cold water and open ocean. O'Connor knows that, and so, deep down, does the steel. The test doesn't come at sea. It comes at dawn. February 3rd, 1943, 05:58 a.m., Bethlehem Fairfield Shipyard. A thin frost coats the hull like powdered glass. The yard is quiet in that rare moment before torches flare and cranes wake up. Frank O'Connor stands alone on the slipway, hands in his coat pockets, breath fogging the air. This is the cold that splits ships. If the steel is going to complain, it will do it now. He listens. There is always noise in cooling steel, ticks, pops, sharp metallic clicks as plates contract. O'Connor has learned to read those sounds the way a farmer reads weather. Most hulls speak loudly at this hour. Sharp, irregular snaps that travel along seams like warning shots. This hull does not. The sound is there, but muted, slower, even. You can almost feel it, the difference between tension and balance. A welder arrives first, boots crunching on frost, then another. They climb onto the hull, stamping their feet, rubbing hands together. One of them pauses. "Frank," he says, "you hear that?" O'Connor nods. "I hear it." "What I don't hear," the man says slowly, "is the bad kind." They walk the seam together. No hairline fractures, no crystalline edges, no zippering along the weld. The steel has held. By mid-morning, inspectors arrive, clipboards out, faces set in expectation. They know where to look, they always do. They don't find anything. One inspector checks again, annoyed now. He taps the weld with the edge of a ruler, listens, then moves on. Another Liberty ship, finished days earlier using the standard sequence, has developed a crack overnight on a neighboring slip. Word spreads fast. Men gather. Supervisors curse quietly. Then someone notices something strange. "That one's clean," a foreman says, nodding toward O'Connor's hull. How clean? Dead clean. The contrast is impossible to ignore. Two ships, same steel, same weather, same yard. Different outcome. By afternoon, O'Connor is called into a small office overlooking the slips. The heater barely works. The windows rattle in the wind. A Navy lieutenant and a production supervisor sit across from him. "Walk us through exactly what you did," the lieutenant says. O'Connor doesn't embellish. He doesn't claim credit. He simply explains the sequence, the breaks, the pauses, the way heat was allowed to move instead of being trapped. The supervisor frowns. "That's not approved procedure." "No, sir," O'Connor says evenly. "It isn't." The lieutenant drums his fingers on the desk. "You changed it anyway." "Yes, sir." There's a long silence. Outside the window, another hull is being cut open to repair a crack. Sparks fly. Men curse. Time bleeds away. "How many ships have you done this on?" the lieutenant asks. "One." "Why?" O'Connor meets his eyes. "Because I was tired of watching them break." The lieutenant looks away first. That evening, a quiet order goes out. Not written, not announced. Certain crews are told to experiment with staggered welding where practical. No memos, no signatures, just words passed down the line. By the end of the week, 3 more hulls are built using O'Connor's sequence. None of them crack. The yard notices. So does Washington. Engineers arrive with notebooks and cameras. They measure residual stress. They run tests. They argue, quietly at first, then with growing urgency. The math catches up to what a dock worker had felt in his bones. Stress wasn't being removed, it was being rearranged, and that made all the difference. Within a month, the welding sequence is revised across multiple yards, not credited to any one man, just process improvement. That's how wartime bureaucracy works. But the results are immediate. Liberty ship failures drop sharply, overnight. Launches accelerate. Convoys form faster than planners expected. No miracle announcement is made. The steel simply stops breaking. One evening, O'Connor scans at the rail as his first quiet ship slides into the harbor. The hull meets the harbor with a deep, solid sound. No shudder, no scream of metal, just displacement. He watches tugboats take her in tow, smoke drifting lazily from their stacks. Somewhere across the Atlantic, men will eat because of this ship. Tanks will roll because of this ship. Ammunition will arrive because of this ship. They will never know his name. That's fine. O'Connor turns away as the yard lights flicker on. Another hull waits behind him, and another, and another. For the first time in months, he feels something unfamiliar in his chest. Relief. But the war is still on, and one quiet fix is about to be tested in the harshest place imaginable.
March 1943, North Atlantic convoy lanes. The ocean doesn't announce its tests. There is no warning shot, no polite signal that conditions are about to turn. One moment, the sea rolls heavy but manageable, slate gray under a low sky. The next, it rises, steeper, darker, driven by wind that cuts across the decks like a blade. A Liberty ship named SS Jonathan Edwards pushes into it anyway. Her bow lifts, then drops hard, steel plates shuddering under thousands of tons of force. Green water crashes over the forecastle, freezing almost instantly along railings. The hull flexes,
Not visibly, not dramatically, but enough that every man aboard feels it through the soles of his boots. This is where ships fail. Not in shipyards, not in calm harbors. Here, where cold water slams steel again and again, where stresses accumulate silently until something gives. Below decks, a junior engineer pauses mid-step, listening. He has sailed enough winter crossings to know the sound he's waiting for, that sharp metallic crack, the sudden scream of tearing steel that turns routine motion into emergency. It doesn't come. The ship groans, yes, all ships do, but the noise is deep, even. A living thing under strain, not a breaking one. You can almost feel the difference, like a bridge that sways instead of snapping. Captain William Hargreaves grips the bridge rail, eyes narrowed against sleet. He's lost ships before. He's seen hulls fracture without warning, watched seawater pour through seams that were solid hours earlier. He doesn't trust this ocean. He certainly doesn't trust a mass-produced freighter built in weeks by civilian labor. Yet hour after hour, the Jonathan Edwards holds. When the storm finally passes, the ship carries on with nothing worse than ice buildup and exhausted men. No flooding reports, no hull damage, no frantic damage control teams hammering patches into place. Just another day survived. Across the Convoy, it's the same story. Ships that once might have fractured under these conditions now ride it out. The difference is subtle, invisible to anyone not trained to feel it. But it's there. Back in Baltimore, reports trickle in slowly. Shipping logs, damage summaries, dry technical language that hides something extraordinary. No hull fractures reported, no seam failures, cold weather performance within tolerance. Someone notices, then someone else. By April, the pattern is undeniable. Liberty ships built under the revised welding sequence are surviving Atlantic winters that had previously broken them apart. German U-boat commanders don't know why sinkings aren't translating into supply shortages the way they should. Allied planners do, quietly. Frank O'Connor reads a brief summary pinned to a notice board weeks later. No names, no details, just numbers. Failures reduced, throughput increased, convoys stabilized. He stares at it for a long time. The war is not won by this. Not by one change, but it is sustained by it, prolonged, fed, kept alive long enough for everything else to work. And that is harder to measure than explosions or victories. Back on the slips, the yards move faster now, not recklessly, but confidently. Welders still work at a brutal pace, but the steel behaves differently. It settles instead of snapping, complains instead of screaming. The miracle isn't that ships are being built quickly. It's that they are surviving. O'Connor watches another hull take shape, sparks flying, heat blooming and fading in controlled rhythm. No one calls it his method. No one thanks him. That's fine. He never wanted credit. What he wanted was quiet steel. And out there, beyond the gray horizon, the Atlantic is learning to accept it. The strange thing about saving a war is that it rarely looks like saving anything at all. By the summer of 1943, the shipyards are louder than ever. More slips, more cranes, more hulls moving down the ways with relentless regularity. Posters still shout about speed and sacrifice. Newspapers still praise production numbers that border on the unbelievable. But something fundamental has shifted beneath the noise. The crisis has faded. Not announced, not acknowledged, just gone. Liberty ships are no longer splitting apart at the pier. Trial failures drop to near zero. Cold weather fractures, once whispered about like a curse, become rare enough that inspectors stop expecting them. In Washington, the graphs flatten, the red lines stop climbing. That alone is victory. But it is not the kind of victory that gets parades. Frank O'Connor feels the change in subtler ways. Supervisors stop hovering. Inspectors stop prowling the slips with suspicion in their eyes. The yard breathes easier. Men joke more, fewer ships are pulled back for emergency repairs, fewer nights are lost cutting out bad steel. The work is still brutal. It is just no longer desperate. O'Connor never receives a commendation. No letter, no handshake from a visiting official. His name does not appear in any report. The revised welding procedure is now simply standard practice. It exists without an origin story, the way most wartime improvements do. That is intentional, because celebrating it would mean admitting how close things came to collapse. Engineers continue to refine the process. They formalize stress relief sequencing, document heat distribution, and teach it in training manuals. What began as a dock worker's intuition becomes institutional knowledge, cleaned, abstracted, stripped of personality. That is how the system protects itself. Yet among the men on the line, the truth circulates quietly. They know who first said, "What if we did it differently?" They know who stayed late listening to steel cool. They know who took the risk. Sometimes, during a break, a welder will nod toward O'Connor and say to a newcomer, "Watch how he listens to the hull." No explanation needed. The war grinds on. Liberty ships pour across the Atlantic in numbers that stagger even Allied planners. Fuel, food, trucks, tanks, aircraft, everything the coming invasions will require. Normandy is still a year away. Italy bleeds slowly. The Pacific burns. And the supply lines, those fragile, invisible arteries, hold. German U-boat commanders notice the shift too. Sinkings continue, but they no longer strangle the flow. Convoys reform faster than expected. Losses are absorbed. The math no longer works in Germany's favor. No one traces that back to a welding sequence. They trace it to American industrial capacity. That's not wrong, but it's not complete, because capacity without reliability is just noise. O'Connor understands this better than most. He watches ships slide into the water day after day, hulls flexing as designed, stresses flowing instead of concentrating. He knows each one represents more than steel. It represents margin, time bought, risk reduced, lives not lost because a seam held instead of tearing open. One evening, a young Navy officer stops him near the slips, awkward, unsure. "Sir," he corrects himself, "Frank, I just wanted to say, we've been told some of this started here." O'Connor shrugs. "Started a lot of places." The officer nods. "Still, thank you." That is all. No cameras, no paperwork, just an acknowledgement that will never exist on record. O'Connor watches the officer walk away, then turns back to the hull in front of him. A new ship, another name, another crossing ahead. He runs a gloved hand along the seam, feeling the faint warmth of recently welded steel. It feels right, and in wartime, that is the highest compliment a piece of metal can receive. But the full meaning of what he did will not be clear until much later, when historians begin asking why something that should have failed didn't. By the winter of 1944, Liberty ships have become ordinary. That, more than anything else, is the miracle. They no longer make headlines when they launch. Newspapers have moved on to bigger stories: battles, invasions, cities liberated and cities destroyed. A freighter sliding into gray water doesn't compete with that. It doesn't try to. It just works. Across the Atlantic, ports receive cargo with a rhythm that would have seemed impossible 2 years earlier. Convoys arrive on schedule. Supplies stack up faster than planners can move them forward. Commanders stop writing contingency plans for shortages that never materialize. The system holds. No one remembers the winter mornings when hulls cracked at the pier. No one remembers the panic in inspectors' eyes when another ship was flagged, another launch delayed, another convoy recalculated. Success erases its own history. Frank O'Connor feels this erasure personally, though he never names it that way. He is older now, not much, but enough.
The work has worn grooves into him. His coat hangs looser. His hands ache in the cold more than they used to. He is still a foreman, still a civilian, still invisible to the official story. That is exactly where he belongs. One afternoon, a group of visitors walks the yard. Engineers, officers, men from Washington. They stop at a hull midway through construction while someone explains standardized welding procedures, stress management, efficiency metrics. O'Connor listens from a distance. The explanation is flawless, clean, logical, scientific. It contains no trace of doubt, no mention of fear, no hint of the moment when everyone realized something was wrong and no one knew how to fix it. That part has been removed, which means it worked. You can almost feel the difference between a miracle and a system. Miracles are noticed, systems are trusted, and trust, once established, is invisible. The Liberty ships have crossed the Atlantic so many times now that they feel inevitable. They are no longer fragile, no longer experimental. They are assumed. That assumption feeds everything that follows. The build-up in Britain, the stockpiles in France after D-Day, the relentless push across Europe. All of it rides on steel that does not crack. O'Connor watches another ship depart at dusk, tugboats guiding her gently toward open water. He does not follow her progress. He never has. He prefers not to imagine storms or submarines or cold seas pressing against welds he once watched cooling in the yard. He trusts the steel. That trust was earned. Sometimes late in the day, he walks the slips alone, listening. He still listens. He always will. The sound of cooling steel has not lost its meaning for him. It is still a language, still a warning system. The younger foremen notice this. They don't laugh. They learn. The war ends months later, not with a crack or a collapse, but with surrender papers signed far away from shipyards and slipways. When it does, the Liberty ships don't stop sailing. They carry troops home, aid outward, the infrastructure of peace. Long after the headlines fade, they keep working. Years later, much later, engineers will write papers about brittle fracture and welding sequence. They will cite studies. They will draw diagrams. They will teach students why certain things are done the way they are. Very few will ask who first changed the order, and fewer still will understand why that mattered more than any formula. Because the real miracle was not the ship, it was the decision, a quiet one, made without permission, corrected not by authority, but by listening. Frank O'Connor never tells the story himself. He wouldn't know how to frame it. He doesn't think of it as heroism. He thinks of it as work done properly when the rules were wrong. When the steel finally stopped breaking, the war didn't notice. That is how you know it mattered.
If this story stayed with you, take a moment to let us know. A simple like helps this history reach people who may never have heard it. It tells the algorithm that these moments still matter. Subscribe if you want to stay with us. Here, we uncover the moments in the Second World War when everything changed, when there was no return. These are not just battles. They are human realizations, sacrifices, and truths buried beneath decades of noise. If you feel comfortable, leave a comment. Tell us where you're watching from. The United States, the United Kingdom, Canada, Australia, or somewhere else entirely. Tell us if someone in your family lived through this war. You're not just watching a video, you're helping keep these memories alive. Because once the stories disappear, there really is no return. Thank you for watching.